In the world of AI, we've always heard one thing, right? Bigger is better. But what if that's just completely wrong? Welcome to The Explainer. Today we're diving into a pretty radical new idea. What if the future of AI isn't one single giant brain, but a whole team of smaller, smarter, more efficient ones?
I mean, for as long as any of us can remember, the story of technology has just been about scaling up. More power, more memory, more data, the whole 9 yards. We've all been trained to think that more size just automatically equals better performance.
But, this isn't the first time we've seen this movie. About 20 years ago, computer engineers basically hit a physical wall. They just couldn't make a single CPU core any bigger or faster. So what do? They shifted to a multi-core approach, getting lots of smaller cores to work together. And that gave us a massive leap in power.
So that whole history with CPUs, it brings us to a really fascinating question for AI today. Instead of pouring all of our time and money into building one single colossal AI, could we actually get better results with a whole system of smaller, nimbler AIs all working together? The answer is way more surprising than you'd think.
Okay, so let's get into the problem. We're kind of hitting a wall. For years, making AI models bigger and just shoveling more data at them gave us these huge breakthroughs. But now, those gains are starting to level off. We're spending more and more for smaller and smaller improvements.
So the obvious next step seems to be teamwork, doesn't it? The idea is, let's just get a bunch of AI models in a room, let them debate a problem, critique each other's work, and collaborate to find the best answer. Sounds like a perfect plan.
But this is where the story gets really interesting and a little weird. This is where that intuitive, obvious solution runs headfirst into a very harsh reality, and it challenges everything we think we know about collaboration.
Now get this, for the huge, top-of-the-line AI models, the big guns, this teamwork approach actually works. As you can see right here, things like debate and having other models verify the work, it helps them catch mistakes and their accuracy goes up. So far, so good.
But now, look what happens when you try the exact same thing with smaller, more efficient models. The performance doesn't just stall out, it takes a nosedive. It drops badly. Instead of correcting each other's mistakes, they end up getting dumber together.
So what in the world is going on here? Well, the researchers found a critical flaw. These smaller models just don't have strong enough reasoning on their own to push back against a bad idea. They fall into this trap of AI groupthink, where one little mistake at the beginning gets repeated and amplified by the whole group until it becomes the consensus. The obvious solution: it fails completely.
All right, so if letting them talk to each other is a total disaster, what do? How do you possibly get them to work together as a team? This is where researchers came up with this incredibly elegant and frankly counterintuitive solution called SLM-mux.
The core idea is, well, it's brilliant and totally backwards from what you'd expect. Just don't let them talk to each other. SLM-mux acts like a smart conductor for an orchestra. It has each AI, each musician, play its part in total isolation, and then it just steps in and picks the best performance. No discussion needed.
And here's how it works. It's a really clean three-step dance. First, each model answers the exact same question a few times, all by itself. Next, the system checks how consistent each model was with its own answers. That's its confidence. And finally, it simply picks the answer from whichever model was the most self-consistent.
Okay, to really get what that confidence check means, let's just imagine this. We ask one of the small models the same question 3 times.
And it comes back with the answer A twice and B once. That gives it a self-consistency score of about 67%. SLM-mux just does this for all the models in the team, finds the one with the highest score, and boom, that's the final answer. It's really that simple. But okay, having a smart conductor is only half the story. You also need the right orchestra. And what the research found is that the composition of the AI team is just as important as how you lead them. Yeah, you definitely don't want a team of clones. A bad team would be 2 models that are both great at algebra, but both terrible at geometry. Their weaknesses overlap. A good team, on the other hand, is built with models that have complementary skills. One is an algebra whiz, the other is a geometry pro. Together, they cover each other's weaknesses and can solve way more problems.
So to actually find these AI dream teams, they built a search algorithm that was basically looking for 2 things. First, Find a team that, when you combine their skills, can answer the widest possible range of questions. And second, avoid teams that get into stubborn arguments, where two models are both super confident but have different answers.
And this is where it all comes together. After all that work, finding the right team, finding the right way to lead them, the results were just wow. Just look at this. This is the real payoff. A hand-picked team of just two small models, led by SLM-mux, went head-to-head with a single giant model that is many, many times its size and cost. It nearly tied it on the tough math benchmark, and on the other two tasks, it actually beat it.
So, this method doesn't just hold its own against the giant models. It absolutely blows other team-based methods for small models out of the water. A 13% jump on a difficult math benchmark is a massive leap forward, and it proves this conductor method is uniquely powerful for these small model teams.
So, what's the big takeaway here? Just like we saw with CPUs 2 decades ago, we might be at a huge turning point. By shifting our thinking from a single-core approach, just building one bigger and bigger AI, to a multi-core approach of smartly conducting teams of smaller models, we could unlock a future for AI that's not only more powerful, but way more efficient and accessible for everyone.